Welcome to the Foundry by Forge College. Today we are looking at KYC integration and dynamic whitelist updates. In our last session together, setting up monitoring tools for Solana deployments, we learned how to keep a close eye on live technology. Today, we are connecting that technology to the real world. A smart contract lives completely isolated on the blockchain. It has no way of searching the internet to see if a user has passed an identity verification, the background check we call KYC. It's like a bouncer who's blindfolded. They know someone is standing there, but they can't see the ID card in the person's hand. Without a secure, automated way to pass that real-world verification over to our on-chain rules, our smart contract is stuck. We can't run a compliant token sale if our code doesn't actually know who has been cleared to join. Imagine an exclusive nightclub. On the left, we have a strict bouncer. That's our KYC provider. On the right, behind a heavy door, is the VIP manager, our smart contract, who oversees the club's interior. The bouncer outside handles all the heavy lifting of checking physical IDs, but the VIP manager inside is the only one holding the actual guest list, or the whitelist. Notice that glowing green line separating them. That is the blockchain barrier. Because blockchains are isolated, the manager inside can't simply look out the window to see who the bouncer just approved. To safely get approved guests onto that inside list, we need to build a messenger. This messenger carries the bouncer's approved names across the barrier without compromising the club's security. We call this messenger an authorized actuator. It's a script, usually written in Node.js, that zips back and forth, carrying glowing packets of data from the front door's ID checker straight to the manager inside. But our manager doesn't take names from just anyone. Before the messenger can hand over an update, it has to pass a strict pre-flight check. The smart contract scans the messenger for a specific cryptographic badge, the whitelist manager role. Only when verified does the manager accept the data packet. If the messenger script is missing that exact badge, the manager instantly rejects the update and keeps the door locked. By requiring this badge every single time, we keep the system secure. Even if the messenger script malfunctions off-chain, the smart contract's core rules remain unbreakable. To keep things running smoothly, we give our messenger a rule called idempotency. It's a fancy word that basically means don't double stamp the VIP pass. Look at this logic. When a name arrives, the script checks a decision node. Is this address already on the list? If the answer is yes, the script does nothing. If the answer is no, it moves forward with the update. We avoid duplicate updates because every time we write new data to the blockchain, it costs transaction fees. Checking the list first keeps our costs down. To be even more efficient, the script batches approved names into groups of 10. Instead of making 10 separate trips, it carries a bundle of names all at once. If the blockchain connection has a minor hiccup, the script doesn't crash. It uses exponential backoff, which means it politely waits a moment and tries again until the delivery is successful. These steps, checking for duplicates, batching, and smart retries, turn a simple script into a robust assembly line that can handle thousands of users without breaking a sweat. While the script works, it creates a meticulous audit log, our ultimate clipboard. This log captures every single detail of the messenger's journey in a format called nd.json. It records exactly who was approved, who was rejected, and the specific transaction IDs. If an error happens, the log notes exactly why. This level of detail is exactly what we teach in Forge College programs. This specific log format makes it incredibly easy for students to test their code in simulated environments before going live. A great audit log transforms a simple script into professional infrastructure. It allows you to mathematically prove your system is working correctly before any real money is at stake. By keeping the security rules on the blockchain while handling the messy logistics off-chain, we create an automated whitelist that is both safe and cost-effective. Mastering this setup is a huge milestone. It means you can confidently connect verified participants with the next steps in their journey, like receiving their tokens through a vesting schedule. To dive deeper into these mechanics and explore more Web3 topics, head over to forge.college to take the next step in your learning. Thanks for being here.